Hi everyone, Alexander Graham here, and just giving a really quick tutorial today in QGIS. Very simple stuff, how to do custom vegetation indices. And well, mainly this is important because there are a lot of software that are expensive. They're licensed software such as ArcGIS, Erdas Imagine, and software like that. It's actually difficult to create your own custom vegetation indices. The raster calculators may require you to subset some of the bands individually out of a composite image, and then then you'll have to make the index that way. But in the case of if you have already a composite image, a composite ortho photo, which is commonly exported in software such as Pix4D, in that case, you're out of luck, right? So a really good way and a really actually free way is to do it in QGIS. So let's go through it. Okay, so just got the QGIS window open here. Note that I'm using version 2.8.2, probably a bit of an older version, but anyways, it'll probably work with all of your versions as long as it's this version or newer. I got the Sequoia multispectral sensor image open here. This is a composite 4-band image. So the bands are already composite, they're stacked together. It has the green, the red, then the red edge and the near infrared bands, and I believe the red edge band is around 730 nanometers. I'd have to double check that, but at any rate, I'm just going to show you guys how to do a really simple vegetation index here. Nothing too complicated. So you want to go up to the raster here on the top, and you want to go to raster calculator. Now, what this raster calculator has done for us that it doesn't do in ArcGIS with composite images is it's split up the 4 bands of the image in your raster calculator. So in that sense, it's actually better than ArcGIS and a lot easier to use in this sense because basically it's a playground. We can do any kind of index that we want. And just for sake of simplicity, I'm going to do just a really simple vegetation index. I'm going to do the red edge differential vegetation index. So what we're going to do here is just do the red edge band, which is actually band 3 in this data set. And we're going to subtract band 2, which is the red band. In fact, I forgot to put brackets, so you want to bracket these. And then you want to divide, create another bracket, red edge plus your red. Close the bracket. You're going to know that that it's going to work because down here it's going to say expression valid. If you've done something incorrectly, such as maybe not close your bracket, you can see here it says expression invalid. So just make sure that everything is set up properly, and also note that you got to use stuff like asterisks and all the operator signs. You can't just put a bracket next to a bracket and expect it to multiply. Make sure you got those asterisks if you're going to be using an index that involves multiplication, right? So right here, very simple, just going to call it the REDVI, and I'm going to just save this out, and we'll be back in a second and I'll show you the result. Okay, so we're just back here and you can see the result already. It's given it as a black and white image, right? Grayscale image, and you can see the min and max range of the data set. So it's looking pretty appropriate considering we're covering for the most part crops. It didn't clip out anything like the roads or the neighboring crops, but in general we got some pretty good data, it looks like here. I don't know much about the data itself. This is actually taken off of the MicaSense website for data samples. But do note that we use the red edge band, and I believe, as I said, it's 730 nanometers. But those bands, they can change. The red edge actually shifts depending on vegetation type, depending on the stage of growth that it's in. So these sensors, especially the narrow band sensors, it may not be true red edge. You gotta actually research with some hyperspectral data first of your plant or whatever you're studying, and then determine what's the true red edge throughout the season. Anyways, enough rambling here. I'll just show you guys how to turn this into a color scale image, because of course we have grayscale right now. Very simple. So let me just go back here. You want to double click your image. I called it REDVI test. and you're going to be wanting to go to the style section here and change your render type and go to single band pseudo color. Okay, and here we're actually doing somewhat of a threshold or supervised classification. But what we're going to be doing is defining our own sort of classes. So what we're doing here, I set my color scale to go from red to green. Typical color scale for sort of NDVI stuff, red is going to be lower, so it's going to be more towards the bottom end. Notice that we have the same min max as right here. So I'm setting the low to this minimum, the maximum to this maximum right here. And then what we're going to do is we can either do continuous, we can go to equal interval if you want, which is what I often do, and I can set as many classes as I want. So let's just say 15, and you're going to click classify. And you can see what it does is it segments out the different colors in the image depending on the radiometric values of your pixels from your minimum to your maximum. So we have that here, and I'm good with it for now. Gonna click apply. Okay, and there's our image. You can see in general that areas that are darker in green are representative of places that are a little bit healthier, and you can see the red. The red is generally a bit unhealthy. You might be getting some soil in here. Also, of course, we didn't clip this out, so there's some roads being classified in there as well. You got middle health areas that are sort of bright or yellow. So yeah, that's our final result, and thank you guys for watching.